All right, so today's webinar is dedicated to the texturing in Artec Studio. Today, you will see real-world examples of Artec Studio's texturing capabilities. You'll get tips and tricks for getting the best results. And we're going to cover handheld scanners, Ray II in particular, some texturing settings, and of course, some quick tips to get you going. So first of all, let's start with the texturing basics. So what is a texture in 3D in general? I think it's really important to understand that right away so that all the content in this webinar, so that everyone is on the same page and it will be easier to move forward if we discuss it right in the beginning. So texture is simply a 2D image, like a photo, which is being projected onto our 3D mesh, onto our model. And texture mapping is used for that. So yeah, without a texture, like if you imagine looking at a 3D model on a screen, without a texture, you will see just some mold, some shape, but it does not have life. So to make it look great for the presentation, of course, we need textures and color for it to really pop. So that is why we need textures. So if a texture is simply a 2D image that is being projected, like a texture atlas is a combination of those different textures in a single master image file. This way, it is easier to store those textures and to display them for the 3D software. So once you create a complete model with a texture in Artec Studio, you're going to get your model and the texture atlas, which is mapped onto your model. And this way, the software later on visualizes your colored mesh as a result. And of course, the colors that we see on a model, they're collected with the 3D scanner texture camera in our case, or an external camera in case of photo texturing. All right, so let's move forward. Why do we need texturing in general? In the context of Artec Studio, texturing is one of the final steps of creating a model. And it is particularly useful when the scanners are used for the industries such as architecture, CGI, jewelry, video games, for cultural preservation, and more. So here is when the texture is really a priority. Sometimes you even pay more attention to the texture in this case rather than to the geometry. So you need really accurate colors for the presentation purposes. And apart from that, the texture is always great, even for presentation. So let's say even in automotive industries, sometimes applying texture might be really great for the presentation to the customer, such as like an auxiliary feature. So yeah, it's always good to have that. So what do we need for texturing in context of Artec Studio? So when we're using handheld scanners such as Artec Leo, Eva, Space Spider, and Spider II, we are collecting frames. So the scanner projects a structured light pattern onto the surface of our object, and then using its cameras, it understands the shape of the object. So the cameras analyze the distortion of this pattern when it's being projected, and this way we know the position of the points in the 3D space. So that's for the geometry. This is how we get our geometry. But at the same time, so in order to stitch those frames together, our scanners collect the frames, as you can see, black and white frames, which are used to maintain the tracking, to stitch all the frames together, and this way you're getting all of those frames properly positioned in the 3D space. But at the same time, Artec Studio also, well, our scanners with Artec Studio also collect the T frames, the texture frames. As you could see right here, they are marked with such a UV icon in the UI, as you could see on the left, sorry. And on the right, you could see that how the black and white frames are marked inside of Artec Studio. And basically, in the context of today's webinar, we're mainly interested in the colored T frames that are going to be used for texturing. So actually, yeah, we collect both T frames and black and white frames for the optimization of the process. So it's much easier to use black and white frames for tracking and for global registration. And this way, we speed up those algorithms. And then we're able to use the colored texture frames in order to recreate color. So with all of that, it allows us to receive a scan, what we call a scan inside of Artec Studio, and you could see how it looks on this slide. So then once we have received this collection of scans, which consists of different frames, we're able to create a fusion, and by merging, let's say merging those texture frames with the fusion, we're able to receive our final texture fusion, our final texture mesh. So Artec Studio automatically, when you're running the texturing algorithm, it automatically maps. First of all, it unwraps the geometry and maps different images onto your texture atlas, onto your final 3D model. And this way you are able to get this nice looking mesh with true to life colors. So yeah, and we know the position of the frames thanks to the tracking algorithm and thanks to the global registration that we do next. This allows us to receive really accurate mapping of those textures on our object. And finally, once you have created your textured mesh, once you are exporting it, if you are picking the OBJ format, you will be able to see this texture atlas, different 2D images that your texture consists of. And this allows us to view our textured mesh in any different software that also supports the OBJ format. All right, so this is it for the basics. Now let's move on to the texturing workflow. We're going to go through this really fast. So the steps are as usual. It's like usual processing steps inside of Artec Studio. First, we scan our object. We erase the unnecessary parts, align the scans if there are several of them, and we run global registration. So here, it's really important that global registration is required not only for the fusion, not only for a good mesh, but it also matters for the final texturing of our mesh. So a poor global registration may harm the final quality of your texture. So not only geometry, but the texture as well, which is why it is important. It is a very important step. And when you're going to run the global registration, ideally, like if you have rich enough and unique enough texture, and the texture really matters to you, it is better to run the registration by geometry and texture at the same time. This way, you're going to get better textures. Of course, that is if the object has suitable rich features. Then you create a fusion, and finally you texture it. So that is the regular workflow. Now we're going to talk about those points in more depth. Okay, so first of all, let's talk about scanning with our handheld scanners. When I'm saying handheld scanners, I'm referring to Artec Leo, Eva, Space Spider, and Spider II. First of all, the first advice which will give you which will give you the most noticeable impact on texturing, is increasing the frequency of texture frames, I guess. So you may find this option on the scanning tab. If you scroll down and extend the advanced settings there on the scan tab, you will see this option called frequency of texture frames. So yeah, as the name suggests, the idea is that some of the frames, so as you've seen earlier, some of the frames are black and white, and some of the frames are T-frames, texture frames that contain color. And here we decide, here we set the frequency for those texture frames which contain the color. Later into the webinar, you will see where it really matters. But right now, I just want to tell you that increasing the frequency of texture frames usually increases the overall quality of your texture. So yeah, by default, it's set to automatic, as you can see right here. And on the right, you can see a rough representation of that. It's not the actual UI, it's just for the demonstration purposes. So the idea is that Artec Studio tells the scanner automatically which frames should be T frames and which frames should be black and white frames. So yeah, black and white frames are much lighter. They take up less space, and it is easier to process the scans which have more black and white frames. While texture frames are more heavy, but of course they give an advantage for the texturing. So this is a trade-off. So yeah, Artec Studio usually automatically decides which frames should be automatic. And once you move the scanner far enough from the previous texture frame, it will collect another one. So that is how it works by default. But if we increase the frequency of texture frames, if we set it to manual mode, 1 per something frames, then we're going to collect frames with stable intervals of time. So I scanned this model with the Spider II. I had FPS, 15 FPS, 15 frames per second, and I set this option to 1 per 5 frames. So this means that I'm recording three texture frames each second, basically. So that is the idea, and it's actually a lot. So yeah, if you're scanning small to medium objects, it's more than enough to get a really good result for the texture. So I would say that 1 per 5 frames is a good starting point for let's say Eva and Spider II, and for the Space Spider, for the first Spider, something like 1 per let's say 1 per 3 frames is going to be suitable. And of course, you could also set up this setting on your Artec Leo in the Leo user interface. The next really important technique during scanning is scanning at a 90-degree angle to the surface. So this allows for better texture projection. This doesn't mean that every frame that you scan should be at a 90-degree angle. This is actually not possible unless we are scanning a painting or something like that. So yeah, it's totally fine if some of the frames are at an acute angle to the surface, but we need to have enough frames scanned at a 90-degree angle as well. So when you're scanning, try to think about that, try to scan at an optimal distance, referring to the histogram that you see inside of Artec Studio, and try to point your scan at a 90-degree angle to each surface that you may find there. So this ensures a good texture coverage, and this ensures that your textures won't be blurred out, won't be distorted, so they will be of the highest clarity possible. And that is actually true for all of our handheld scanners. Next, really important advice about the trajectory, which kind of intersects with the previous one, is keeping the object unobstructed during scanning. So take a look at those two images on the slide. As you could see right here on the right image, it's one of the texture frames that we had in this project. And on the left, you could see the fusion with the artifact of the table obstructing the view. Yeah, so actually such issues may occur if you are scanning, if you collect frames where your target object is obstructed by some sort of an alien body. So if there is a table which is not supposed to be on a scan, then try not to capture it. So ideally, you would not want to have such frames on a scan in order to avoid such issues. Of course, there is a workaround. Sure. So if it's not possible to rescan your object, you always can double-click your scan, find a faulty texture frame which has your object obstructed. You could delete it and rerun the texturing. So this technique would also work, but it is quite tedious and it consumes a lot of time. So ideally, you would want to avoid that in the first place. And a good technique for that is to place your object to place your object on some sort of a base which elevates it from the ground, and this way it will be much easier to not to collect such frames. And of course, you should collect enough relevant texture information so that there is no blind spots on your texture. Of course, if there is simply no angle for a specific geometry part, like there is no frame for a specific angle for a geometry part, then Artec Studio won't know the color of the surface. So that is why try to avoid the blind spots and try to cover your object fully. Okay, now on to the next topic. So lighting is actually important even for scanning. So even lighting allows for better flat color collection. Here is one of the examples of the setups that you could use. So it is important, even though all of our scanners, all of our handheld scanners, which are Leo, Eva, Spider, and Spider II, are those of the scanners are equipped with a texture flash, which allows for which lights up the texture in front of the scanner and allows for a more even color. But still some shadows, depending on the overall lighting in the environment, some shadows might still be present even with the texture flash. So that is why ideally you would want to scan in an environment with soft, even lighting. Now, I'm not saying that it's definitely should be a light box. It's just one of the examples. It could be just a well-lit, evenly lit room, which is also good. But if you have a light box, then it might also be really convenient. So here I've placed this figurine on our Artec turntable, the automatic turntable inside of a light box. This allows for even color, even lighting distribution, and Artec turntable synchronizes with the Artec Studio. So when you're scanning, let's say with the Spider II, once you click to start the scan, either in Artec Studio or on the scanner itself, the turntable will start rotating right after that. So yeah, it's quite easy to collect that. So yeah, this allows for more even colors. Now let's see just a few examples on this exact model. So on the left, you could see this a scan, a fusion, a complete fusion with the texture applied from the scans with no additional light. So you could see that There are some shadows. It's not that bad, like it's pretty good actually, but still there are some shadows which we don't necessarily want in the flat color under the cape, as you could see, and on the lightbox, the area underneath the cape is almost completely flat. So it has a really slight shadow, but mostly it's really well lit. Then if we take a close-up look at the rock beneath the fit, then you could also see more even color distribution on the model on the right, which was scanned inside of a light box. And finally, if you take a look at the shield, then you could see that on the light box, the blacks are not that crushed, and so we preserve more texture information this way, and there is almost no shadow whatsoever over there. So yeah, this is a good way to minimize the shadows, especially if your object is quite complex, as we could see on this example. If your object has rather simple geometry and doesn't have a lot of intersections, a lot of crevices, then generally, like lighting inside, the general lighting inside of a room will definitely be enough. But in more difficult cases, you could always use a light box. Now let's move on to scanning with Artec Ray II. So since we're talking about lighting, let's continue this topic here. Lighting, of course, also matters for the texture for the Ray II. So Ray II is capable of collecting HDR images. Yeah, the best practice to scan with the Ray II is to scan during midday in overcast weather. So actually, if you're scanning at midday and the weather is sunny, it would not be good because the shadows will be really harsh, so they will be really sharp in this case. But in case the weather is cloudy, then it's like the perfect conditions, as you could see right here on the example of this statue. So it's perfectly evenly lit. Yeah, so it's lit evenly from all of the sides, and we won't have to do we will have to do almost no work with the texture after it's applied. We would get a good texture right away, as you could see right here. Here is the final result that we've got in Artec Studio, unedited. So yeah, basically, this is the best practice. But let's say if it's hard to wait, if it's not possible to wait for the overcast weather, in your case, then you could wait for your whole object to be in a shadow. So it's also one more technique which can be used for in order to achieve an even texture. You could just wait the time of the day so that the whole object is inside of a shadow, is covered in a shadow. Then the overall base color, of course, it will be dimmer. It will be darker in comparison with those perfect conditions, but still it would allow you for even color, to collect even color, and later on it will be really easy to edit it. So yeah, that is one more approach that you could take. Now let's move on to the scanning settings of the Ray II. Here I'm going to be really quick. So here the setting that you should pay attention to is called adaptive resolution. So adaptive resolution, when it's turned on, then the resolution for the point cloud also controls the quality and resolution of the images that you collect. This means that if you enable adaptive resolution and you set, let's say, low resolution for point clouds, then the resolution of the images will also be low. So just keep in mind that in case you keep this option enabled, then I would recommend to scan in high point cloud resolution for the best texture results. And in case you need to scan something in a low point cloud resolution, but with high image resolution, then you could simply turn off the adaptive resolution setting all in all. And then independent of the resolution of the point cloud, your image quality will be the highest. So yeah, generally this is done in order to save up some space. Yeah, like lower resolution images take up much less space. So in case the texture is not your priority, then it could be a great way to reduce the size of your projects. Okay, so now as for the scanning positions, as for the trajectory for scanning, it's pretty similar to handheld scanners in a way, in a sense. So ideally, you would also want to make enough scans at a 90-degree angle to your target surface. So as you could see right here on the image on the right, the positions of the scanner are highlighted with those markers, with those like red circles. These are the positions of the scanner. So as you could see right here, we have 4 scans at a 90-degree angle at different steps to our facade. And then we have 4 different positions which are way back, but they are made at elevated, so they are at a different height. Here, the object was scanned at a different height. This allows us for more accurate texture projection, and this allows us for more resolution as a result. And of course, so variety of positions is better for complex geometry. Here we had to do that much positions because we wanted to scan the statues really well, which are located on the top. So we needed a bunch of different positions. So just keep in mind that if we don't see the geometry, we won't see the texture as well. So in this way, even if geometry gets reconstructed with the whole filling, the texture in painting might not work as well. So yeah, that is why, of course, ideally you would want to cover your whole object with scans from different positions so that the texture which is being applied is like 100% true to the original, to your true object. Now let's move on to the texturing settings inside of Artec Studio. Let's go through a quick overview. First of all, we're going to cover the resolution, and in which case we need to set which resolution. Then we're going to talk about the reduced layer option and how to get the best results with it, prioritize sharp images, reuse UV map, and finally, we're going to cover the HDR for Ray II to achieve the best color accuracy and quality. Okay, so first of all, the first setting, I guess, which should be set up is the resolution, because it's the mandatory setting for each of the texturing sessions, because we need to tell the software in which resolution we're going to receive our final texture image. So the most popular one is for small to medium objects is 4K. It's like a perfect balance between between the large size of a file and a good texture fidelity. So for most applications, 4K is usually the golden standard. Yeah, so something lower may really compress. You may lose out on the details, and something higher may not be beneficial for small to medium objects if you're scanning them with a 3D scanner. So yeah, 4K is like a sweet spot for that. But of course, 16K might be also beneficial. For example, in cases when you're scanning environments and outdoor scenes, if you're scanning with Ray 2 and you have a really huge object, you would want to texture that in 16K, not to lose any of the details, not to compress the original texture images, panoramas collected by the scanner. And also, resolutions above 4K, such as 16K, will be beneficial when you're using photo texture with an external high resolution camera. So we won't be covering photo texture in today's webinar, but we're going to have a separate one on this topic. So today we're simply talking about texturing, mostly with the scanners. Now, there is also a reduced glare option, which might really come to use and be a savior for tricky surfaces. So, of course, there are certain objects which have a lot of glare. When you're scanning them, you will see a lot of reflections which are traveling through the object. And when you're applying texture, you will see those unpleasant reflections baked into the texture. So we actually don't want that. We want to receive a nice, even, flat colors, and we want our reflections later on when we apply materials. So yeah, that is why ideally for such objects, we need to get rid of those reflections on the final texture. And we have an option for that. We have a solution. The reduced glare option analyzes the frames collected with your 3D scanner. It analyzes the adjacent frames, which are covering the similar area on the geometry of your object. And when you're scanning a similar area from multiple different angles, the reflection will travel depending on your angle. So Artec Studio will be able to find a glare on each of those different frames, detect it, and then take the good portion of this frame in order to do the texturing. Of course, in order to do that, we need to feed enough frames for Artec Studio to be able to produce a really good result. And that is why, as I've recommended earlier, it is really beneficial to increase the frequency of texture frames for that. So if you're increasing the frequency of texture frames, there is much more positions, there is much more angles. Of course, angles depend on you, but there is much more frames, and ideally you would want to scan your object from multiple different positions and orientations, and then Artec Studio would be able to analyze them and produce a really good flat color result. Also, one more thing about that is another option which is kind of connected to this one. It's called prioritize sharp images. So if you enable reduce glare and prioritize sharp images at the same time, then you might see some weird artifacts. So sometimes if you don't have enough frames, and if you enable both of these options, you might get a weird result for your model, which is fine because, yeah, there is not enough frames for both of those algorithms. So in such cases, I would recommend to pick one, and I would recommend to pick the reduced glare. So just turn on the reduced glare, turn off the prioritize sharp images, and this way you will get rid of the glare, and most likely you will get a good result. But once again, if you have enough frames, if you have a lot of frames, then enabling both of these is not a mistake. It might also work really well. So let's take a look at the example of how it works. Here we have this vase, and as you see highlighted in the red circles, there is a reflection on the paw and on the head, which are baked into this texture. This doesn't look good. So ideally you would want to reduce glare, and as you see, just by enabling this option, the glare is gone. and you get a clean, I guess it's bronze, clean bronze color. So yeah, and this way you might resolve those issues really easily. Yeah, let's see at what happens in case you don't have enough texture frames or angles for your scan. As you see on the image on the left, here we didn't have enough texture frames and angles for the algorithm, and therefore when it was enabled, we see really sharp transitions between different frames. It looks really bad. Yeah, and that is why we need to increase the T-frames frequency in order to make sure to avoid that. And on the right, you could see the results with more frames picked for that, and it's really smooth. There is a nice transition, nice gradient, yeah, it looks true to life. So that is what we're aiming for. That is why increasing frame frequency and using a correct trajectory is really important. Next, we have the prioritize sharp images option. As the title suggests, it just prioritizes sharp images over the blurry ones. Initially, it was introduced for the photogrammetry, but actually it works pretty well with the scanners too, especially with close range scanners such as Spider. So yeah, the principle is basically the same here. You also need enough texture frames to avoid like strong transitions, to avoid unpleasant transitions between frames. And here you also have a slider, which I won't give you a recommendation about which value you should set. It's usually unique depending on the project. So for each project, it might be really different, but the default one works most of the time. So yeah, the higher is the value, the more the sharp images would be prioritized. So just keep it in mind and feel free to experiment with it. So yeah, you can try applying the texture multiple times, tweak your results, and get the best out of it. And here is an example with the Spider II data. So on the left, the prioritize sharp images option was turned off. On the right, it was turned on. And as you could see, the clarity and fidelity of the text on the right is improved significantly. Also, you could see those this dirt on the controller, which is a nice thing, I guess. So yeah, it is the texture is way more defined. You could see slight grain on the plastic right there, and overall it looks way more way better on the right. And this was achieved just by prioritizing sharp images. So no post-processing, nothing at all, just enabling this setting, and this is it. Actually, let me tell you why this happens. So here in this particular project, actually, this is what I've been talking about before. I didn't have enough frames scanned at a 90-degree angle, so I had just a few, and therefore the texture got kind of smeared, and it was easily fixed with the prioritized sharp images because I still had some good frames there, but just not enough for the regular algorithm. So yeah, feel free to experiment with it. It can produce really interesting results and increase your fidelity without altering the resolution of your model. You will get a better result with that. Now moving on next to the reuse UV map. This one is pretty simple. You can enable it in the texturing menu right there. It speeds up the algorithm. So at first it won't be available because there is no UV map for the fusion that you create inside of Artec Studio at first. After the first instance of texturing, your fusion will receive a UV map, and then you will be able to reuse it to speed up the algorithm. So why is that necessary? So it might be really convenient when you texture your model, you see some, let's say you textured it with the reduce glare turned off, you see some reflections, and you rerun it in order to fix that. So just changing the settings and rerunning the algorithm, this setting just helps to run it faster. And in this case, let's say you forgot to pick one of the scans for texturing. Therefore, you have this incomplete color information at the back of your model, and you just reuse UV map and add in another scan in order to cover this area, and you're done. So it's much easier and quicker to use it and run the next instance of texturing with it enabled. Next up, we have the HDR for Ray II. It can also be enabled in the texturing settings. Artec Ray II collects the HDR images, and it's possible to create an HDR texture out of it. It will give us more adjustment settings. As you can see right here, we have color adaptation, light adaptation, and intensity for the HDR. So this gives us much more freedom to edit our texture and to overcome the different difficulties. For example, if there was a poor lighting, you will be able to correct that with the HDR. It gives you much more toggles to achieve a better result. So as you could see right here, you could tune some of those settings, and therefore you will compensate for poor lighting right here in the scene and make the colors really pop and make them much closer to the real life look of your object. And of course, it is also possible to once again, if you scanned your whole object inside the shadow, you will be able to use the light adaptation in order to correct that. Okay, so now I'm going to share a few quick tips for the texturing with you. So first of all, in Artec Studio, it is possible to toggle the lighting using the L hotkey on your keyboard. So once you are in the user interface, you can click it and you can switch between lights turned on and off. Here is how it looks. And actually, why would you need that? Actually, lighting inside of the scene, it can hide, it can mask some of the imperfections on your texture, because you will see the shadows inside of the scene, which does not relate to the texture of your specific object, such as here. So you won't be able to understand if this shadow is a problem with your scan, or it is something coming from a lighting in the scene. So that is why I would recommend to inspect your textures with lighting turned off, as you could see on the left. And here we can clearly see the shadows, the dark areas on the actual object rather than in the scene. And you could see that the reflections are way more prominent here. And this would suggest us that we need to run the reduce glare in this case. So yeah, that is why it might be really convenient. And one more thing about that, you can disable the lighting for textured meshes in settings. So if you go to the settings menu in Artec Studio, then you navigate to the UI, to the user interface, and scroll down to the display section. As you could see on the screen, you could disable lighting for textured meshes. This will make the lighting work independently for the textured meshes from the global settings on your scene. So it doesn't matter whether your global lighting is on or off, your meshes will also be displayed in flat colors. So yeah, this is not something that everyone likes by default. So that is why it is customizable, and you can enable it. Personally, I keep it enabled, and it's really convenient. It's really convenient for working with the textures. So yeah, finally, I want to share a few quick tips about the export. The two most popular formats for the export would be OBJ and PLYVC. So if you're aiming at the highest texture quality, at the best fidelity of your texture, and maximum compatibility with different software, websites, and so on, I would recommend to export in OBJ. It's one of the most popular formats, so it will generate an OBJ file, PNG texture atlas, and an MTL file with the material properties. Yeah, but it takes quite some space. So that is why you could export your mesh in PLYVC to save a lot of space. But keep in mind that this format is not that widely acceptable. That's first thing. And the second thing is that the quality of the texture will be reduced depending on the amount of vertices inside of your mesh. So that is why it's kind of a trick if you don't care that much about the texture fidelity, you could export it in PLYVC. But if you would like to achieve the best results, ideally you would want to export it in OBJ and PNG. Okay, so this is it for today's webinar. Thank you for watching this webinar.